Hello, now the second part of the genetics chapter, we will do a dihybrid cross. I told you, what is a monohybrid cross? A cross in which you consider parents considering one pair of contrasting characters. Okay? Okay? What is a dihybrid cross? A cross between two parents considering two pairs of contrasting characters. First case we saw tall and dwarf. We only considered tallness and dwarfness. So one pair of opposites. So monohybrid cross. Second case, let's see what Mendel did. He took a pea plant having yellow round seeds. They were yellow and they were round. And crossed it with another pea plant having green wrinkled seeds. Green and wrinkled. So I am considering two pairs of opposites here. Yellow and green is one pair of opposites, and round and wrinkled is two pairs, is a second pair of opposites. Therefore, I am considering two pairs of opposites. Therefore, children, this is called dihybrid cross. Okay, dihybrid cross. The parents yellow round, pea plant having yellow round seeds, and pea plant having green wrinkled seeds. This is the phenotype, yellow and green wrinkle, because I can see that. But I represent it with factors, with genes. This is genotype. Yellow, big Y, just like there tall I took big T, round, big R, green, small y, wrinkle, small r. I guess you know now, by now, why I'm writing this capital and why I'm writing this small. When he crossed a pea plant having yellow round seeds with another pea plant having green wrinkled seeds, the F1 generation, he found all the plants to have yellow round seeds. Now see children, it got the big Y gene, it got the small y gene. It got the big R gene, it got the small r gene. So this is heterozygous. That is hybrid, yellow round. This is also yellow round. Phenotypically both are same. Yellow round, but this is heterozygous. So hybrid yellow round. This is pure, big Y, same. Look at this, same gene. So this is homozygous, this is heterozygous. It has got both. It has got gene for yellow as well as for green. It has got gene for round as well as wrinkle. But yellow has expressed, so it is dominant. So therefore I wrote this with capital. Gene for round as well as wrinkle, but round is expressed, so it is dominant. Okay, so this I've written, this is recessive now. Wrinkle could not be expressed, so I've written this in small. Okay children, so this is what, this is the F1, first filial. Just like in the first case where he self-pollinated the F1 plant, in this case also he'll self-pollinate the F1. So we'll get F2. F2 के लिए big Y, big R, small r self-pollinated, cross with same big Y, small r. Okay, but here see what genes you will get. Big Y will go with big R, big Y will go with small r, small y will go with big R, small y with small r. So you will make a 4 ka like this. 16 squares you will get. Okay. You will get 16 squares. Okay, so see how you do. I took big Y big R, big Y small r, small y big R, small y small r. Okay, here big Y big R. Okay, now Y goes with Y, big R goes with big R. Y goes with Y, big R with small r. Big Y goes with small y, big R with big R. Big Y goes with small y, big R with small r. You understood? This will be done better in the class. It's very difficult for me to explain this in a video, but I think if you practice it and you look at if you look at there is a chart given in the textbook, so please have a look at this. But I just wanted to show you how the gametes I got. So you get 16 squares here. There only you got 4. Okay, so see what he got. He got 9 plants having yellow round seeds, 3 plants having green round seeds, 3 yellow wrinkled and 1 green wrinkled. So the phenotypic ratio he got, that case that was monohybrid cross. phenotypic ratio he got was 3:1. Here he is getting 9:3:3:1. Okay? Okay? Um, and third law is law of independent assortment. From here, only in dihybrid cross will you get the law of independent assortment. The characters are assorting themselves independently, irrespective of the previous combination of the parents. What was the previous combination? Yellow round, green wrinkles. But they had assorted themselves. Here, yellow has gone with wrinkled and green has gone with round. See. Yellow has gone with wrinkle, green has gone with round. So the characters are assorted. So the distribution of characters in one pair is independent of the other. The distribution of this character is independent of this. So therefore you got a different combination altogether. You got green and round, yellow. So remember, this is law of independent assortment, only applicable in a dihybrid cross. Okay? So I hope you all have understood. The genotypic ratio is not in your syllabus for this, so don't bother to do it. Okay, what's mutation? Any change in the gene, okay, or in the chromosome, which leads to its physical effects. Okay, any change in the gene or in the chromosome which leads to its effects, physical effects, and which is transmitted to the next generation. So a change in the gene or in the chromosome which is transmitted to the next generation is called a mutation. Best example, sickle cell anemia. Okay, because there is just, it's called point mutation. There is just one gene which is different, okay, or one nitrogen based sequence which is different. So because of that, the RBCs, which are normally biconcave disc shape, become sickle, like a sickle. It's used for cutting grass, so become very weak and they can be easily broken. Okay, so that is sickle cell anemia. Even radioactive, very high intensity radioactivity can cause mutations in us, so it can lead to cancers. Okay, now in every cell of our body, okay, except one cell, in every cell of the body except the gametes, there are 46 chromosomes. Remember, out of those 46 chromosomes, 44 chromosomes have nothing to do with gender. They have the general body character, so they are called autosomes. 2 chromosomes have to do with gender. They determine the gender. So out of 46 chromosomes, 44 chromosomes are called autosomes and 2 chromosomes sex chromosomes. In females, only in females, you will have X and X. There are 2 sex chromosomes, X and X. So therefore she is a female. In males, there are 46 chromosomes, out of which 44 are autosomes and 2 sex chromosomes, X and Y. Okay, in males there will be X and Y, and females will be X and X. Now how is this gender determined? The sperm can either contain X or either contain Y when there are new sperm, because meiosis, because this 44 plus XY will by meiosis become half. So either it will be 2 types of sperms, one containing 22 plus X and the other containing 22 plus Y. So which kind of sperm? If the Y containing sperm fuses with the ovum, then it will be a boy. Okay, and if the X containing sperm fuses with the ovum, then it will be a girl. So this is a sex determined. This is how sex is determined. Gender is determined. Okay, and it is a sperm. Remember, either Y containing or X containing. So which determines the gender. I hope you've understood hybrid cross, and I hope you've understood this properly.